Please welcome Program Manager, Microsoft Visual Studio, Unni Ravindranathan.
Hello, everyone. I'm Unni Ravindranathan, and I'm a program manager on Visual Studio. My team is responsible for some of the tools and runtimes that you might have used to build apps for Windows. Things like Blend, the XAML editor, the tools used to deploy applications, NuGet, WPF, things like that. Today, I'm going to be taking you on a demo-driven tour of an end-to-end experience to build a universal Windows app in Visual Studio. But before we start doing demos, I'm just going to give a couple of minutes of an overview, a context into the universal Windows platform, and then dive into showing demos for building a universal Windows platform application. Now, since this is a Xamarin conference, of course, I'm going to start with a Xamarin solution, a solution that has an Android and iOS application already built out, and then I'm going to add universal Windows platform support to it. I'm going to build an app sharing a bunch of code with my Android and iOS application. And then along the way, I'm going to be showing Visual Studio 15, our new version. I will highlight some of the new capabilities we are adding in Visual Studio vNext, Visual Studio 15, that we think will make it even more fun and productive to build a universal Windows platform application. With Windows 10, our vision with the universal Windows platform was to make it possible for you, the developer, to build applications that run on all of our devices that run Windows 10. It could be a PC, it could be a phone, it could be an IoT device, it could be HoloLens and Xbox as we disclosed at build. It's the same set of APIs, it's the same set of tools and the SDK that enable you to build applications for all of these devices, no matter what kind it is. Now, of course, as a developer, you'll want to think about the unique capabilities and user experiences for each of these devices and how you can tailor your application for any of these devices. But it's the same skill set, C#, XAML, if you're doing HoloLens, Unity maybe, to build applications that run on all of these devices. It's the same store that you go and deal with when you want to monetize the application. You want to submit the application to the store, analyze usage, work with in-app purchases, things like that. It's the same experience across the board. And of course, it's all powered using Visual Studio. Xamarin is super exciting for us because as a .NET developer, I've been doing .NET since the last 10, 12 years, and it has never been a better time to be a .NET developer. If you're a .NET developer, you can build an application for the cloud using ASP.NET, ASP.NET Core, but also for all devices out there now today with Xamarin. So of course, you could build an iOS and an Android application, and you guys are experts at that. I'm going to show you how you can build a universal Windows platform application. You can share almost all of the business logic across these three devices using either shared projects or portable class libraries. But of course, each of these platforms allow you to expose the native APIs so you can build the best possible experience for your customer. I'm not going to be doing Xamarin Forms today, so I'm going to be doing native UI for Windows XAML or Windows XAML. But you, of course, can use Xamarin Forms to share even the user experience across devices. We are going to focus today primarily on native UI on Windows, though. And finally, I promise this is my last slide, it's super easy to get started. With a single checkbox in Visual Studio, we acquire all of the tools required for you to build an application, the SDKs, the emulators, and Visual Studio itself. So it's really easy to get started. If you haven't built a universal Windows platform application before, I'd highly encourage you to go give it a shot and let us know what you think. As promised, we're going to do demos. So let's switch over to the demo machine. And before I start building a universal Windows platform application, I'm going to show you the application that we're going to build today. Just to give you context, I'm going to use my Android device. And it is an application that we built about a month ago for our Build conference. It is a Xamarin solution. It's open sourced on GitHub, so feel free to go give it a shot there. It is an application for a car driver. The scenario here is you as a car driver are making a number of trips. The car has all sensors that let you get information along the lines of the fuel consumed, the distance traveled, your speed and such. We collect all this information and we send it to the cloud. In the cloud, we have an IoT hub running in Azure that's processing all these messages that are coming from these devices and essentially using machine learning on them to eventually get you some results. Things like better directions to get to places, or your preferred routes, or even your driving skills. We try to compare good versus bad practices all using Azure ML and try to predict models around what your rating should be as a driver. So to show you this application, you can see all of it's an Android application right now. You can see all of the trips listed in here. You can go to the menu. It's fully native Android experience. And by the way, it is built as a native Android app, not using Xamarin Forms, this particular application. You can look at all the trips. You can, if you want to sort of record a new trip, you can set up recording for the trip. You can get data from the car sensors, upload it to Azure. And then finally, you can sort of see the skills of the driver per se. So in a particular case, we'll give you sort of like a rating as a driver and things like that. So fairly simple application. Today works for Android and iOS. We are going to build the UWP version of this today in Visual Studio. So let me switch over to Visual Studio and get started. Like we discussed, it is a Xamarin solution. There is an Android and iOS application there today. There are a number of projects that are allowing us to share code across these applications. We'll take a look at that in a second. But let's first create a new project for Universal Windows application. So to do so, I will go into the New Project dialog in Visual Studio and select the language that I want to go for. So in this case, I'm going to select C#. But you can build an application using Visual Basic or even C++ or JavaScript. Of course, we all love .NET, so let's pick C#. So I'm going to pick my driving. I'm going to give it a name and hit OK. The first dialog that you see in Visual Studio when you create a project, it should be very familiar to you as an Android developer. We allow you to select the version of the SDK that you want to target, as well as the version of the platform that is required for running the application. Windows is going to ship newer SDKs on a periodic basis with newer capabilities, newer APIs and things like that. You can select the version of the SDK that you want to compile against using the first option here. Now, of course, if you select a lower version, you'll get fewer APIs. And as you go higher, newer and newer APIs will get added. Let's go ahead and pick the last released version of the SDK, and then configure minimum as well. Now, what the minimum platform indicates is you are guaranteed that the application will not be offered to a device that is running anything lower than the minimum version of the platform. It's in our best interest to try to make the application available to as many devices as possible, and people don't upgrade all the time on a constant basis. So we'll try to create an app that is adaptive. It works across a range of devices, across a range of platforms, and we will light up functionality that's specific to a particular version of the platform. So let's go ahead and create a new project and give it a second. So the next thing to do is to bring in all those components that we had created to share code across the Android and iOS application. To do so, let's first take a look at what those components are. Most of the code for the Android and the iOS application resides in this portable class library. If I open it up, it's using your typical MVVM type of artifacts. So for example, there are some models. There is a bunch of view models. About 80% of the code of this application, at least the client part of the application, Azure part is different, is shared across the Android and iOS application. And it's all contained within the portable class library here. We also have, because we are talking to devices, the way you do that on Windows and Android as well as iOS is different. We can't put that code in a portable class library, so we have a shared project. Let me quickly show that as well. If I open up the device implementation, you will see that there is a couple of if clauses, because we have to conditionally include libraries that are specific to Android, iOS, and Windows. Now, this is a very thin library. It doesn't really do much, but it's still required to light up the functionality of the application. And of course, there is an abstract interface that we provide that allows us to call into this from all of our implementations without having to repeat all that code. So it's a fairly reusable pattern that we have done here. But again, it is device-specific for that part. And of course, beyond that, I'm not going to spend time on these, but there is a couple of projects also that are, again, portable class libraries that talk to our Azure REST endpoints and things like that. Now that we've taken a look at that, let's go ahead and add these projects that we just saw into our Universal Windows platform as well. I'm going to go to the Reference Manager in Visual Studio. And I'm going to select some of the shared projects, actually all of the shared projects. Like I said, almost all of the code is going to be shared across iOS, Android, and Windows, as well as the portable class libraries, like the My Driving library, as well as the ones that allow us to talk to the Azure endpoints. And finally, we're going to add the device-specific implementation of the ODB sensor, the sensor that reads the data from the car for things like gasoline consumption, as well as the shared library that allows us to call into these APIs in an abstract way. OK, so that's one set of references that I've added to the project. There is yet another set of references, the Xamarin plugins and other NuGet libraries that I'm bringing in. Just to see these, let's open up the Android project and take a look at the packages.config. You will see a number of NuGet libraries that we have brought into the Android project as well to allow us to do things like human-readable strings and Xamarin plugins to access things like geolocation API. So we have all of those things already included in our Android project. We have to do the exact same thing for a Universal Windows Platform application as well. One of the things about the Universal Windows Platform is we are essentially using a newer version of NuGet that we call NuGet v3 in our Universal Windows Platform application. ASP.NET Core and Universal Windows Platform are both built on top of .NET Core and are built on top of NuGet v3. We hope to bring NuGet v3 to Xamarin users as well soon, but for now, the world is slightly different, not that different from a user perspective, but slightly different from a package author perspective. In NuGet v3, all of the references are really stored in project.json. And by the way, the CS proj is not touched at all. Anytime you add a reference, it's completely separate without actually muddling your existing project. So it allows us to do a number of operations in Visual Studio that were hard to do in the packages.config NuGet v2 world. Let's open up project.json. Right now, it's fairly empty. Now, I could spend a bunch of time going to the NuGet package manager and adding each of these references manually. But to save time, I'm just going to use an existing project.json file that I already created. Here you go. So it has a bunch of references that I'm just going to copy and paste just to save some time. So let me go ahead and copy and paste this. I'll describe these in a second. All right. So just a couple of them are really interesting to talk about. There are typical NuGet libraries that you might have used as a .NET developer. For example, Humanizer allows us to show human-readable strings instead of like things that are with, like for example, you could see 4 months instead of the number 4 and things like that. We can do a lot of things there. The important one to talk about is the Universal Windows Platform. UWP applications or Windows 10 applications are built on top of .NET Core, and essentially the entire framework is offered up as NuGet. There is nothing to install on the machine. It's all a set of NuGet packages packaged together so that you can easily consume that in your application. And finally, like we discussed, there are a number of Xamarin plugins that we are also using. The same set of plugins are used in your Android application or iOS application as well. Let's go and close that and bring up the NuGet package manager to highlight one more important point. As soon as I made those changes, the NuGet package manager reads that, and these are the set of packages that we just took a look at. The one I want to call out is the Microsoft.NET Core Universal Windows Platform NuGet package. Like I described, the entire set of APIs for building a UWP application are delivered to you in the set of NuGet packages. This allows us to innovate on the .NET side at a very fast pace in a synchronized way with the innovations that we're doing for ASP.NET Core. So whenever we fix a bug in ASP.NET Core, you get it as a UWP developer. Whenever we fix a bug for a UWP developer, you also get it as an ASP.NET developer. Over the past month, we shipped our first update to the libraries. And I'm going to just show it to you how easy it is to consume. All you have to do is click the update button in the NuGet package manager. And what's really happening now behind the scenes is you're getting essentially a new version of .NET Core all delivered to you without you having to worry about anything else. It's as simple as that to get a new .NET API in this world. I'll wait for that to complete. And there you have it. You essentially have a set of new APIs now available to you as a .NET developer. And it's local to your application. Nothing really needs to change on the device or anything like that. OK, so now that we have done that, let's go ahead and run the application. Let me switch over to x86, because we're going to run it on the PC first. Note that I haven't really done anything. I'm just going to build and run this application. And then we're going to start adding content to make this application come to life. Let's give it a second here. OK, so it's a fairly blank application. And now we're going to start adding some UI to it so we can sort of showcase some of the other concepts as well. So let's stop debugging and bring up our XAML. Just like Xamarin Forms, of course, XAML originated with WPF back in 2006. We do have a visual design surface. It's completely what you see is what you get, and a XAML editor. I'm going to showcase some of the new capabilities that we're building in Visual Studio 15 that I think you'd love. By the way, I should mention this thing. I don't know if you know about this or not, but Xamarin Forms uses the exact same XAML editor that UWP uses as well. So things that I'm going to show today that are new to Visual Studio 15 will also come to you as a Xamarin Forms developer when we are done with Visual Studio V next. So that's a pretty good thing about this whole thing. So let's go ahead and create a simple text block and a button. I should mention that the screen that I'm trying to create first is the one where you are recording your current trip. So you press the record button, you start getting data from the sensor, and it starts updating UI. So it's a very simple screen. In the interest of time, you're going to start simple, and then we're going to scale it up from there. So what I really want to do is when the button gets clicked, I want to invoke a method that calls into my view model, and it starts doing data bindings and updates and things like that. So let me go ahead and rename the button to record. Now, I could have done everything in my visual designer, but I wanted to showcase some of the new features that we're building for the XAML editor as well. So I'm going to fall back into the XAML editor. Let's go ahead and add a namespace. So I'm going to add XMLNS view model. And I'm going to complete it to a view model that I've already defined in my portable class library. The first thing you will notice is the Roslyn light bulb that lights up in the XAML editor as well. The light bulb suggests fix-ups that you can do to your XAML. So in this particular case, we created a namespace, and we're not really using it. I can bring up the light bulb, and it's suggesting a fix-up for me to remove the namespace that I did not use. So we're going to bring a lot of these suggestive tips and hints to the XAML editor as well, things that you might have used in the C# experience in Visual Studio. Now, of course, I'm not going to remove the namespace because my intention is to use it. So let's go ahead and do that. I'm going to set the data context of the page to the object that I'm going to bind against. So let's go ahead and set the view model as the data context. By the way, here's another thing that we're doing in the XAML editor. Without actually me typing the prefix and then the type that comes after it, I just type the name of the view model. We'll pick it up. And when you hit Enter, we'll complete the prefix for you. A number of these useful capabilities like search and filtering and prefix completion are all coming to the XAML editor in the near future. Now that I've set up the data context, the next thing to do is to set up some data bindings. So let's do that. Let me go back to the text block that I created here and set the data binding to display the distance that was traveled as I'm recording my trip. So let's go ahead and create a binding. And we have full IntelliSense for data binding. So I can just go and select the property that I want to bind against. In this case, I want to bind against distance. We have very tight integration between the XAML editor and the C# editor. So I could hit go to definition from anywhere in my XAML. Because my property is located in a portable class library in my view model, I can navigate to that location right from within my XAML editor, get some context, look at what's going on, come back, and update my UI going forward. Now that's done, let's do a final thing, which is to add an event handler for the button. I'm going to call my event handler on record. I'm not going to use any specific MVVM patterns or anything like that here today, but of course you should consider doing that if that's what you would like. And now let's go ahead and hook up the view model to the event handler that I just added. To do that, I'm going to get the data context that I'd set in my XAML, which I can just access using the data context property. I'm going to cast it to my view model. In this case, I'm going to call it current trip view model, I think. Let's see if that's correct. Yep, that seems correct. And then once I get the view model, all I need to do is call the start recording method. So I can start recording the trip as soon as the button is clicked. The view model is in the portable class library. It's the exact same portable class library that's used in my Android and iOS application. And all I'm doing is calling it from my UWP application. Now that's done. If I run this application, you'll notice that it'll work, but it still has an issue. I don't really have a car or a sensor on stage here, so I need to simulate that input. Let me just quickly hook that up as well. To do so, we have built a simulator just for the purpose of the demo here, because we don't have those devices in play. Let me just use that by hooking it up to the simulator. To do that, I'm just going to go to my service locator, and I'm going to add the interface implementation. So OBD device, and that's the implementation just for the purpose of simulation, for the purpose of this demo. Let me complete these namespaces as well. And let's run this application. Now, of course, it'll work, but you'll see an obvious problem, which is the next thing that we're going to go and fix. Give it a second here. When I click record, the data binding updates in real time, and you'll see that it's updating in real time. Now, the font is really small. Folks in the back of the room probably cannot see it. So let's go and fix that. To do that, I'm going to use a couple of new unique capabilities of Visual Studio. Let me go ahead and dog the application to the right of the screen. And to the left of the screen, I have Visual Studio, just to make it easy for you to see it. I'm going to use the UI debugging tools in Visual Studio to locate the element and then fix that up using my XAML editor. When the application is running, we have inserted a toolbar on the application, so you can quickly select any element in the running application, no matter where it's defined. So in this case, I can go ahead and select. Let me just bring up the live visual tree here so you can see what's going on. As I'm selecting things, the live visual tree, which is a visual indication of all of the elements in my application, is updating in real time to show me the selection that I just made. If I select the button, it updates to the button as well. It makes it really easy for me to know where my UI is coming from, so I can go and fix it up. Let's go fix up the problem. I'm going to go and select the text block, and I'm going to hit this little button over here that synchronizes the XAML to no matter where it's coming from. It could be coming from a resource dictionary. It could be coming from any page. It doesn't matter. We'll take you right to the location in your XAML where that particular element is defined. Now, historically in Visual Studio, to fix this problem, you'd have to stop debugging, restart the whole debugging cycle. In Visual Studio 15, we're bringing edit and continue to the XAML experience as well. Let's see that in action. I'm just going to go to the end of the text block, and I'm going to start typing. I'm going to set font size to 32. And as I do it, my application updates in real time. It doesn't require me to stop debugging, restart the whole debugging cycle. Makes it really productive for me to go make those changes. You can make pretty much any XAML editor change, and it'll update the application in real time. Let's see that in action. Let's go ahead and create a stack panel. Notice that as I'm typing, I'm doing it in a very natural way. I'm introducing all kinds of errors. Typically, you would do it as you're typing things. And it doesn't really matter. We'll keep up with your typing experience, and we'll update the UI as we move along. So let's go ahead and select the stack panel and move it below the text block here. So basically, I'm wrapping the text block in a stack panel just to show that I can do a number of layout operations. Let me add a new tab as well. And let's add a new element. Oops, that's too much. Let's add a new element. Text block, text equals, binding. You get full IntelliSense again. So I'm going to say, let's say, fuel consumption. I'm going to set the font size to something large. And then I'm going to close this tag. As soon as I complete it, my UI updates in real time. The application is still running. The data bindings are still updating. And I'm able to make all these UI changes that allow me to finesse my application, add functionality without having to stop, restart the debugging cycle. OK, now that's done, in the spirit of the demo, let's fast forward a little bit. I'm going to copy and paste some more XAML changes instead of making them on the stage here. It essentially is the exact same XAML file. I'm just going to add some more content just to make it look slightly more pretty. And let me just see that in the visual designer. You can see it essentially is like just a couple more data bindings and a button that's styled slightly better. So let's go ahead and run this application. Give it a second. And when the application comes up, if I click on the button, the data bindings will update. So it essentially, all I've done is put a map control, a couple more text blocks, a button, and hooked it up. Pretty much the exact same thing I did before. Now, the thing to note here is this button is not really keyboard or mouse friendly. When I'm moving the button, essentially mouse over the button, I'm not getting any visual feedback of what's going to happen. That's what we want to fix next. To fix that, let's open up this project in Blend. Blend's our design-focused tool that has a number of unique capabilities that allow us to do a lot more UI design on top of XAML and UWP and WPF. I'm going to showcase just a couple capabilities of Blend. I'm going to do editing of a template, and in particular, its states, so that I can show you how I can visually change, all using a WYSIWYG editor, the interactive nature of controls, in this case, the button that we just saw. Let me just zoom in to the thing that I want to edit and select the button. Let's go ahead and edit the template of the button and see how it looks like as I'm making changes. So let me go ahead and edit template. For some reason, there we go. Oh. All right. And as soon as I edit the template, you will see that all of the states are listed. I can go and change a particular state. To change a state, all I have to do is select the pressed state. That's the one I want to change, because I want to change the visual feedback when the user clicks on the button. I select the element that I want to modify. In this case, I want to modify the ellipse. And I just go and make the change. So in this case, I want to change it to a green. Of course, I won't do this in real life, just to make it easy for people to see in the back of the room. I'm just going to make it a green. And when the user mouses over the button, when the user moves the mouse of the button, I'm going to change the ellipse to a blue. That's all I've done. Simple changes. Let me come back out of editing the XAML, and let's run this application. All using the WYSIWYG editor and tools and Visual Studio and Blend, I was able to take a fairly simple user experience and pretty it up, add some functionality. And as you can see, as I'm pressing things are changing. I was able to bring this application to somewhat of a state where it's now functional. Let's stop debugging. Oops. Oh, it's building, so let's give that a second. I'm sorry, I accidentally pressed the wrong button. Did I press the wrong button? That's fine. Let's go ahead and kill it from Task Manager for a second, in the interest of time. There we go. All right. Something is wrong with my mouse. I'm sorry about that. OK. That's interesting. Oops. Please excuse us. It's Visual Studio 15 preview. Let's bring it back up again. Fast forwarding a little bit more, I'm going to open up sort of like a further advanced version of the application that I've made some more changes, and I've added some more screens and things like that using the same gestures that we saw before. And now I'm going to test it on a couple of other Windows devices. Give it a second for the project to load in Visual Studio. There we have it. So the application is loaded. And now I'm going to test it on, like I said, a couple of devices. Now, normally I would have done a phone or something like that. But I thought, why not a HoloLens? Like, why can't we take this application and deploy and test it on a HoloLens? That probably does not make that much sense for this application on the HoloLens today as it's designed. But who knows, sometime in the future it might. So instead of a HoloLens device, I'm going to use a HoloLens emulator, just because it's going to be hard for anyone to see if I was to use the device. So let's go ahead and run it and see how it looks like when the application is running. The exact same application, same code base, just a different Windows device. And there you have it. It's the HoloLens emulator is booting up. The application should be deployed, fingers crossed, in a second. And you should be able to see the application running on the HoloLens emulator. Just a second. Fingers crossed. Is it going to work? Yes, it is. Phew. There we go. So that's the same application running in the HoloLens device. It's not super useful in terms of I have to, so for example, if I want to give input to it, I can't really interact with it in 3D space. So I have to kind of simulate it using a mouse, and there are some natural interaction mechanisms built into the emulator. But it's the same app running in the HoloLens. Now you can start like customizing and tailoring it for that device. Finally, we're going to take this application and deploy it to the Xbox. Now, the reason I'm deploying it to the Xbox is I wanted to show a couple of APIs that are specific that we want to think about when we talk about tailoring for the Xbox. So to do so, let's go ahead and deploy to the Xbox first. To deploy, I'll just switch to remote machine. I will bring up the properties window for this particular project. And all I have to do is give the IP address. That's it. It's over Wi-Fi. We're going to deploy it to the Xbox. Let me go ahead and press play. And then if we don't mind switching over to the Xbox for a second. Fingers crossed, it should go over to the Xbox as soon as over Wi-Fi. If there are no issues, we should be able to deploy and activate the application on the Xbox. Let's give it a second. It's a real demo, so it's going to depends on Wi-Fi. Still deploying. There we go. It's going through. So the application is now activated on the Xbox. The debugger is attached to it. And now I can start debugging the exact same application running on an actual Xbox, all from within Visual Studio. If I switch over to the controller, the very first thing that you'll notice is a problem here. Like, I've created sort of a splash screen, but I did not think about the controller as an input mechanism. When I press A, nothing really happens because my application doesn't know that it needs to deal with controller. So that's an issue that we need to think about as a developer to sort of tailor the application for the Xbox. Let's do that. I'm going to stop debugging. And I'm going to bring up, if you can switch back to the PC, please. I'm going to bring up Visual Studio, the exact same solution. Let me go and open up one of the pages for the splash screen of the application. And I'm going to add some code to make it such that it responds to the controller input and does something. So let's go ahead and add window. Now, by the way, this is not the best way of doing a splash screen, but we'll live with it for now. window.current.core window. Oops. Dot key down. Let's just listen for the key down event for the in the interest of time. And let's just say if args.virtualKey equals virtualKey.gamepad A. We're going to go to the next screen. So I'm going to just say frame.navigate, type of, and then the next part of the splash screen. So I'm just going to say get started too. That's all I need to do. And I'm now going to navigate to the second screen when I press A on the controller, which we'll see in a second. By the way, if you're on the Xbox and if you've used it, like every time you press a key, you also get some sort of vocal feedback. You get like that little bing sound when you press the key. You do have to consider implementing that as well, just for the application to look rich and native to the Xbox. Let's do that. In Windows, we have made it really easy to add those common sounds for devices out there. So I'm going to add element players sound, I think is the name of the API. Now, the problem is this API was added in a newer version of the SDK. Remember I showed you the dialog that allows you to pick versions of SDKs? I've run out of options here. Either I could implement this functionality from scratch, or I could light up this functionality on using a newer version of the SDK. I'm going to choose that option. To do that, I'm going to go back to my project properties, and I'm going to change from the SDK that I'd originally selected when I created the application to something newer. Now, this is a preview SDK. We haven't released it yet, but we will do that soon. Let's go and select that. If I go back to Visual Studio now, I should see element sound player. I made a mistake. Element sound player show up in my IntelliSense. This API only exists on a newer version of the SDK, so I can now use it. .play, and then I can just say .invoke. If I was to run this application on the Xbox and press A, I should see a sound pop up when I run it on the Xbox. Now, there's a problem with this code. If this same app was to run on a device that does not have the API, this application is going to crash. We, as developers, will need to add some guards in place so we can prevent the crash from happening on a device that doesn't have the API. Remember that this app is going to be offered to all developers running any version of Windows 10, and so we have to take some preventive actions here. We provide a set of APIs that allow you to check for the presence of an API before you can call into that API. I'm going to use that here. So I'm going to say if windows.foundation.metadata.api information is type present. I'm going to say if this particular type is present, that's only when I'm going to call this API. Otherwise, I'm just going to skip that particular call. And I'm going to give it a name. So in this case, windows.ui.xaml.element.sound.player. So I'm going to wrap this in an if check so that when the application runs on a device without the API, it won't crash. Let me just make sure I don't make any typos. Windows UI XAML element sound player. That seems about right. So let's now go ahead and put a breakpoint here and deploy it back to the Xbox. We can stay with Visual Studio here. Just trust me that the application is running on the Xbox. Give it a second. The second F5 is actually, oh, did I mess something up? Oh, never mind. That doesn't look lucky enough. But anyway, if I was able to run this application on the Xbox and I was able to press the A button, it'll skip to it'll essentially hit that breakpoint because that API is present on the Xbox, and I was able to successfully meet that check that I added and execute that particular piece of code. One final feature I wanted to showcase before we end the demos for today. Visual Studio has great diagnostic tools that help you profile your applications. If you have performance issues, CPU, memory, etc., we have a ton of tools that we have built for you that help you profile applications. Oops, that's not what I wanted. All of these tools are available to you. What we find is developers don't often spend the time to use these tools. They don't actually know that they have issues, performance issues, and things like that in their applications. So in Visual Studio vNext, we wanted to make it easy for us to bring information at the fingertip of the developers so they can go take preventive action for potential performance and performance issues, localization, accessibility, things like that. Let me show you that experience. To do that, I'm going to switch back to my local PC, and I'm going to start testing this application. Oh, one more change. Let me just go to app.xaml.cs and actually skip the start page. Let's directly go to the, let's say, past trips menu view, because this particular view has a performance issue that I wanted to showcase. Let's go ahead and run this application. This time I'm going to run on the PC, though I could run it on the Xbox. Clearly, there are some issues with the Xbox that I can't deploy. But anyway, when the application comes up, Visual Studio has built-in debugging profiling tools built into the debugging experience. I can go and look at the diagnostic tools, which, by the way, are shown by default. Let me just resize this a little bit. And we can see a number of different pieces of information being floated to you. Now, when we are done, we will just have today, there's a lot of noise because it's a preview. But eventually, imagine if it looks something like this. We show you some issues in your application inside this window that you can take action on. Some of these issues are performance issues. Things like you're doing things that you should not be. They cause issues that you might not know. You should consider taking a look and addressing them. Some of them are accessibility issues. If I was a person with disabilities using this application, I will have issues navigating and working with the application. Let me just ignore the accessibility issues for now. Now that I recommend we absolutely should consider fixing all of those. Let's go ahead and take a look at this particular issue. It's telling me there's a list view in my application that's doing something that's breaking virtualization. I'm doing something that's causing all of the items to be realized in my UI without any reason for that. If I double-click, we will take you right to the place in XAML where that particular problem exists. So in this particular case, if I just resize this back again, there is a items panel that I accidentally set to a stack panel that breaks virtualization. If I did not know or care about this issue, it would take me a long time to diagnose the issue. So we want to learn from the most common mistakes that developers out there do today, and then bring them back to Visual Studio so people can benefit from the knowledge that we have built and quickly find and fix performance issues as well. So that's some of the capabilities of Visual Studio and the experience for building a universal Windows platform application. If you can switch back to the slides. The sample that I showed today was published as a part of our Azure end-to-end example. By the way, it's really comprehensive. It allows you to deploy using Azure Resource Manager, a whole cloud stack that lets you do your own service for monitoring data from different sensors. But we do have a Xamarin sample as a part of it that I highly recommend. Download, play with it, take a look at what it means to build a UWP application. We have a ton of resources on dev.windows.com. I showed deploying to a HoloLens or an Xbox, but it really is a lot more than what I just showed. Tailoring for a device is a lot of work. And it takes a lot of good practices, design practices that we've articulated on dev.windows.com that's worth taking a look at as well. And then we have a ton of samples for all of the APIs on a scenario-by-scenario basis that you can also take a look at. I'd like to thank you for coming to the session, but let's make this a conversation. I'd love to hear your story. If you've not built a UWP, what's holding you back? What can we do to sort of make it easy for you? What's in Visual Studio that you like and don't like? Our research team is on site. They would love to talk to you. So please do take the time to sign up and give us some feedback. We'd love to hear from you and make our tools and runtimes even more better. And finally, I'm going to open up the floor for any questions. Again, I'd like to thank you for coming to the session. And let's build a UWP app today. Thank you. If you have a question, if you can come to the mic, which should be located, or if you can I'll repeat the question as well for everyone else in the room.
Oh, thank you.
Thank you.
All right. So UWP is great, but there's a lot of different user interface idioms. There's a HoloLens, there's a phone, there's a desktop, there's tablets. Are there APIs to decide what am I working with? You know, besides the reactive, you know, on your thing, the tap to click is a different demo.
Yeah.
What are the APIs around doing that?
Yeah, absolutely. I mean, our general recommendation is you should try to do this in a device abstract way as much as you can. So your application kind of lights up for devices in the future as well. But absolutely, there are ways to check for, especially if you think about a 10-foot experience on an Xbox, you really need to sort of think hard about it. So yeah, there are ways to check when your application is running on the Xbox. I didn't show this today, but if I was to look at the code, there's a snippet of code in there that says, is 10-foot experience? And that essentially checks for the application running on the Xbox. So you can light up the user experience specific for that. There is a number of ways to tailor your UI as well without checking for the device itself. But absolutely, you can take the extreme approach and create different apps if you want. That's possible as well. The important part is the same SDK, same code that you reuse across all these devices. Thank you. Yes, please. The mic went. So your question is, in your company, you have a reason to access devices that are not available to Universal Windows Platform apps?
Because we are doing Medic Labs, we are connecting to external devices, to USB devices, custom drivers, all this stuff that prohibit us from using store apps, universal apps. And kind of then we are not only able to not use this, but we also cannot use all this new technology. My question is, are there any plans to kind of bring this also to classic desktop development?
So that's a great question. So I'll answer that in two different ways. One is, so just to repeat the question for the online audience, like, is there any ways to bring API access or device access to Universal Windows apps, or can we bring this technology to work with classic desktop apps as well? To answer that question, the first part is, with Windows 10, we are actually opening up a more and more richer set of APIs so that you can do all of this in UWP apps. So in this particular case, I'm using Bluetooth, and I'm communicating to the device. So my hope, and we should connect offline, is you should be able to light up your API for your device or your sensors and things like that for UWP apps as well. But at the same time, we are also bringing more APIs that were available only to UWP apps to desktop apps as well. So for example, I don't know if there's Project Centennial, which is the ability to take your Win32 applications and put them in the store. A sister effort with that particular project is to enable you to call more UWP APIs from your classic apps as well. But I'd love to understand the scenario a little better more, so I can be more prescriptive, in terms of which is a better fit for your. So if you can connect with me offline, I'd love to answer that question. Any other questions? Yes, please. So in my particular case, so the question is, you have an application that today works for Android and iOS. Yeah, so your options include either working on that as a PCL or as shared projects. Yeah, so the question is, there are a ton of APIs that don't exist today if you're actually targeting a PCL, because it's the lowest common denominator across all of these .NET runtimes. What's your options? One good thing is we are doing a ton of work to address this exact problem. My suggestion would be to take a look at the .NET overview talk from Build that talks about some of the work that we are doing, some long lead work that we're doing here. But short term, your immediate solution includes either shared projects, which actually, to be honest with you, let you share a bunch of the code using if-defs. And generally, you can do all of that, or PCLs. We don't have a great story today, but certainly something that we're working on going forward as well. Yes. Thank you. I think my time's up. I will be waiting in the Visual Studio Lounge. I'd love to talk to you. Again, thank you.